it's my pleasure and honor doing this training. This is the first time we are doing an interactive training. We think interactive training is a lot more effective than just my speaking. So we will. Once again, for the last time, before we start, the training today is an interactive training. You need to either download a Kahoot app on your smartphone or join using www.kahoot.it, and the game pin is 810265. So that is how we will be conducting the training. And with that, we will start. I think people have been waiting. So, well, good morning, everybody. My name is Ashutosh Garg. I work at Furnace Improvements. Furnace Improvements completed 25 years of training of business in US and India. So we thought of doing training and interacting with you. So we want to talk to you, interact with you, and see what you feel. So we have this 90 minutes training. I'm planning to have about 4 sessions of 90 minutes each, and we will hope we will cover most of the things. In addition, I want to thank you. We have received almost 120 questions from you. They are all very good questions. So we will try to answer those questions and post them on our LinkedIn page and Facebook page, and that will we will be able to answer all your queries and continue our dialogue. So you can always send me more questions and we will try to answer so many of these questions. Fire heaters, as all of you know, is a very unique equipment. It is the only equipment which can be easily overfired. It has been in the news for last 50 years for several reasons. It could be, it is a major energy consumer. So fired heaters they consume energy. Second, when they consume energy, they are also major polluters. So right now, as all of you must have heard about greenhouse gas emissions. Prior to that, for the last 30 years, we had been talking about NOx emissions. So fired heaters have been in attention for last as long as 50 years now. Other thing about fired heaters is it is the only equipment in the refinery which has open flames. So with that being said, it is the only equipment, and when you open the PEEP door, you are exposed to the flames. Also, you can increase the capacity of fired heater just by opening the fuel gas valve. This is the only equipment where you can continue to increase the firing rate and keep on getting more heat duty. Uh, so that is another feature of fired heater. And it also has, because of this, it also has a number of problems. So what we want to do is we want to start And my first question is a poll question for you. Uh, what are the typical problems in fired heaters? So on your phone, you can select one which kind of uh, you think it's the most important problem or the most pressing problem or what you have experienced in your uh, time. You can write it down. You can click it. I only had 4 selections available here. I think we have another slide for the 4 more problems. But what we want is let's identify the problems. Let's hear from the end users. Let's find out what they think are the problems rather than my telling that these are the problems. So please, on your phone, you can select one of the 4 answers. And that way we will know what are the pressing problems in fired heaters. It could be positive pressure at arch. You could be worried about high flue gas temperature in stack. Uh, I can tell you so many of my colleagues in India, because of the high fuel gas cost or high energy cost, are really, really worried about flue gas temperature leaving the stack, and they want to cool it down almost to ambient if it's possible. So we will discuss that as well. So we have 34 answers. We will just see how people rate. So 8 people think positive pressure at arch is the problem. 13 people, 13 votes for high flue gas temperature in stack. 19 people, high tube metal temperatures. And some people, 8, are kind of thinking heater pass outlet temperature variation. So thank you for your vote. We will move to the next. So you can see these are the problems which are very common. I added some more problems in fired heaters and things like flame impingement, charge limiting, short run length, bowing of tubes. So just think about what could be happening in your fired heaters and what are the issues which you are facing. So we could identify and then uh, have more attention on these topics. As you all know, for furnace improvement specializes in fixing of fired heaters. That's what we do for living. We are always improving the performance of fired heaters, whether we are fixing the short run length issue or flame impingement. All right. So 67% think flame impingement is a big problem, and I agree very much with them because we also feel flame impingement has been exacerbated ever since we got the low NOx burners. Ever since we got the low NOx burners with double or triple the flame length, flame impingement problem has been uh, experienced in number of heaters. And then the short run length, that's another, I think maybe a direct relation coming from flame impingement. So thank you again. Good response. So where do we use fired heaters? You know, given a choice, I think process engineers won't like to even put a fired heater. I mean, they may want to use a heat exchanger, or something similar. So uh, let's find out where are the fired heaters being used. So most of the 50% application is in preheating charge to a distillation column, maybe like a crude column or vacuum column. Some places it could be preheating charge to a reactor like a hydrotreater or hydrocracker. Some could be sensible heating of fluid, which is like maybe a hot oil heater. And then the other application, which is producing ethylene or hydrogen. So I'm happy there are three people who kind of have ethylene applications. So if you have a fired heater, why don't you let me know what is the outlet temperature of the fluid in your fired heater? To what temperature do you heat the fired heater? It appears to me that I have only given 30 seconds, so you need to act quick. Maybe next time I can add more time, But uh, since we have limited time, I kind of this thing. So most of the heaters, as you can see, heat the fluid to about 600 to 800 degrees F. That's typically. There are some heaters, maybe like coker heaters or maybe platformer heaters, where we go up to 1000 degrees. Less than 600 are typically hot oil heaters or maybe reboilers. And then 14 to 1600 range is in the steam methane reformers or ethylene crackers. Those are specialized testing. So you can see that we have applications of fired heaters with different outlet temperatures. So my question here is, can you achieve 900 degrees outlet fluid temperature using steam or hot oil? Is it true or it is false? Well, nobody thinks we can get up to, most of the people think we cannot get up to 900 degrees outlet fluid temperature using steam or hot oil. And I think it's very important to understand that process engineers use heat exchangers as their first choice. And in the heat exchangers, you can have steam heating, you can have hot oil heating. But after 600 or 700 degrees temperature, uh, the hot oil start coking up and the steam pressure keeps on going up. To achieve 900 degrees, the fluid has to be at least at about 1000 degrees so that we can have the approach. So that is one reason we find that uh, the heat exchangers cannot be used in place of fired heaters. This reminds me of a story, and it was there was a Russian engineer who designed a nuclear-powered refinery. He said, we will just put one nuclear reactor in the center of the refinery, and I will supply the heat to all the users from that reactor. But he ran into problems, and the problem was he could not find a suitable fluid who could heat or transfer heat at 900 degrees or even 1000 degrees. So he ran into problems. I mean, even molten salt cannot do it. So that's one reason why fired heaters cannot be replaced with heat exchangers. So just to give you an picture on refining industry in the US, uh, we are in the survival mode. The number of refineries have been coming down. Uh, 40 years ago, I think there were more than 300 refineries in this country. Today, we have only 120 refineries operating. The good news is the refining capacity in the US has more or less remained steady or even has gone up. That means the existing refineries are being revamped every 5, 7, 10 years to increase the capacity. So my guess is approximately there are about 2,200 heaters in the US, out of which 90% of the heaters are natural draft. Uh, 8% of the heaters are with forced draft and only 3% heaters are with the air preheater. This picture is very different when you go to Asia. In Asia, you will find, because of the high fuel gas cost, 90% of the heaters are balanced draft, or 85% of the heaters are balanced draft with air preheating system because the fuel gas cost is very, very high. Average size of heater in the industry is about 72 million BTUs. The forced draft or the balanced draft heaters tends to be bigger at about 110 million BTUs. So that is a picture. So fired heaters is nothing but a large heat exchanger. They are used for high temperature heat transfer. The energy for heat transfer comes from the combustion of fuel, and radiation heat transfer plays a very significant role. And we will talk about many variations uh, of fired heaters, single fired, double fired, top supported, bottom supported, vertical and horizontal tubes. So we will talk all about that. Uh, so here is a guess. You want to take a guess. What is the temperature of the flames? I'm looking for the adiabatic temperature where before giving out the heat. So some people think, okay, most people think the flame temperatures is in the range of 1500 to 2000 or 2000 to 2500 or 2500 to 3000. The real temperature of the flame before it gives out the heat is in the range of 3000 to 4000 degrees F or 1650 to 2200 degrees C. So you can see the flames are really, really hot. Uh, if you look at methane, ethane, we will go more into that. They typically tend to burn around 3200 degrees. If you talk about carbon monoxide, you talk about hydrogen, you talk about ethylene, propylene, acetylene, you will see that range in 4000 degrees F range. So these are the adiabatic flame temperature we are talking about. So flames are really, really hot, and that is why we are able to heat up to 1500 or 1600 degree F in ethylene crackers or 1400 to 1500 degrees F in steam reformers. So flames play an important role in heat transfer radiation, So What is the typical temperature in the radiant section or a firebox? I'm talking more about the refinery heaters. What type of temperature can we expect in the refinery heaters and this is after giving the heat, after the flames have given out the heat. What is the temperature? So the correct answer is around 750 to 950 degrees centigrade, and most of you got it right, or 1400 to 1800 degrees F. That's the right temperature. Below this temperature, the radiant heat transfer is not very effective. And we will talk more about it, but anything less than below 1400, the Stephen Boltzmann equation or the radiant heat transfer is not very effective. So that's where I think we kind of keep it around 1400 to 1800 to get our heat transfer.